In some of the early videos I showed you how instead of using integration by substitution, you can just guess your way to the answer. And the reason why you're able to do that was because I've given you easy integration. So rather than taking a long time doing use substitution, you can just guess your way to the answer. It's much quicker. But you can only do that when it's for simple cases. For example, if you look at this, when you differentiate this bubble, it will give you 3x squared. And notice that you've got an x squared conveniently placed right here waiting for you. So here, if you differentiate this, it would be 5x to the power 4, and notice that you've got x to the power 4 waiting for you right here. And then if you differentiate this, it would be 3x squared, and you've got an x squared waiting for you right here. You see, when that happens, you can just easily guess your way to the answer. It's much quicker than using use substitution. But now I'm going to give you one where you can't simply just guess your way to the answer, because when you differentiate this, it will be a 4. You see, if you have a 4 here, or if you have a constant like 7 here, you can guess your way to the answer. But here, you've got an x here. So it's not an easy case like over here. So here you've got no choice but to use substitution. So let me show you how you can do this. So let me just rewrite this block here as to the power of a half. To the power of a half. So now from here, hang on, from here we would use substitution. So let's u equals this thing here. So let's u equals this thing here. So from here, differentiate both sides. So du, and then when you differentiate this, it's just simply the number 4, and then you've got your dx here. So differentiate both sides. That will then give you this. We need to replace this dx. So divide both sides by 4. That will then give you this. Later on, we can put this into the dx, and then we can put the u into this bubble here. So so this thing here will become u to the power of a half, and then when you put this into here, it will then give you this thing here. So you can visualize this as being one block, another block, a quarter, du. We need to work. Oh, this is a constant here. We're integrating with respect to u. So this is just a number. It's a constant. It has nothing to do with u. It doesn't vary along with u. So you can just take the constant out. So that will then give you this. So that will then take us to here. But the thing is, we don't want to work in terms of x. We need to work everything in terms of u. So to replace this x, we would go back to here and then make x the subject. So if you add 1 divided by 4, add 1 divided by 4, that equals x. So now you can put this into the x. So that will then give you this. So notice that everything here is in terms of u. And then now just simplify this. Rewrite this as this thing here. And then and now you've got 3 blocks multiplying with each other. 1, 2, 3. This block here is just a constant. It has nothing to do with u. So you can actually drag it outside of the integral. That will give you this. So now multiply this out. This times this. This times this. That will then give you this. And then it's just a matter of integrating each individual component. So when you integrate this, it will then give you this. Integrate this, it will then give you this plus your constant. And then now simplify basically. This times this will then give you this. This times this will then give you this. And then earlier we said let u equals this. So now we can put this into the u. That will then give us this thing here. And then put this into the u. That will then give us this thing here. So that's how you integrate the whole thing. Okay.